something different. In this case it's given, so you should know what do you mean by this. I hope so you have revised the previous lectures for it. Is reached with the switch open at t equal to 0. Find the loop currents. And it said find the loop currents. So when switch is closed, we have 3 loop, 1, 2, 3, I1, I2, I3. You need to find the 3 current, that's it. That's a simple sum. 2 cases, t equals 0 minus, t equals 0, that's it. You don't need to go t greater than 0 plus. You only need to solve t greater than 0 plus only when it is asked. It is you need to solve di upon dt or d square upon dt square, only in that case. When it is asked only till I of 0 plus, you just need to solve till case 2, I of t equal to 0 plus. I hope you have kept that in mind. Okay? So let's start with t equal to 0 plus. Type 12. For t equal to 0 minus condition, your circuit is in steady state, right? If it is in steady state, that means the capacitor is fully charged, it won't accept current, your inductor will allow the current. If capacitor won't accept current, that means the circuit will become open circuit, and an inductor will allow the current, that means it will become short circuit. So let's draw the circuit. The circuit will be 6 volt, 2 ohms, 4 ohms. Capacitor open, again capacitor open, switch open, inductor short, steady state. That's a circuit. Inductor short circuit, capacitor open circuit, capacitor open circuit. So there are 3 currents, I1, I2, I3. So I2 0 minus will be equal to 0 amperes. I3 0 minus will be again 0 amperes. Both circuit are open. But what about I1, my dear friends? I1, I have a closed circuit. So let's apply KVL. If I apply KVL, guys, so what exactly will be getting? Applying KVL in mesh 1, we get add both the resistance. So you'll be getting 6i1 equal to 1 voltage source. Your current enters into negative. Yeah, wherever it enters, exactly vice versa. So you'll be 6. So your I1 0 minus will be equal to 1 ampere. So this is nothing but your current across inductor 0 minus. So your current across inductor which you got is 1 ampere, because in case 2 at t equal to 0 plus, I need to replace my inductor with its current, because your inductor was in steady state. So this the current which I got from I1 is the current flowing across the inductor. So in step 2, instead of inductor, I need to draw a current source having a downward direction, value 1 ampere. So we were supposed to find the value of all the loop currents. So we have find out all the values for case 1. I1 of 0 minus, I2 of 0 minus, and I3 of 0 minus. Let's go for guys case 2. In case 2, it's given t equal to 0 plus. When it said at t equal to 0 plus, my dear friends, so at t equal to 0 plus, let's have a circuit. For this case, your switch will get closed, 2 ohms, 4 ohms. What about the capacitor? If I talk about capacitor, I need to replace the capacitor by its voltage source only if it was in steady state, and it is given it is in steady state. So for capacitor, I need to find the voltages. Have you done it? No. Again, for the second case, you have again a capacitor. You need to have a voltage. You need to have a voltage. For an inductor, you got a current source having value 1 amperes. But what about capacitor in both the cases? So that's something new point in type 1. You don't have a capacitor directly connected to the voltages. We have two loops in this. In earlier case, you had a capacitor which is directly connected to voltage source, which was directly connected to it. So you could get the directly value for it. But in this case, you had two capacitors. This was the first sum till type 11 where you have two capacitors in a network. So let's solve when you have two capacitors in a network, how to find the voltage across them. So let's do it. If I need to find capacitor's voltage, so basic law says if the two capacitors are in series, that means they will absorb the same charge. If two capacitors are in series, they will absorb the same charge. So I can say Q1 is equal to Q2. So charge across one capacitor I can write as C1 into V1, second C2 into V2. So if I take the ratio of V1 upon V2, I will get C2 upon C1. So V1 upon V2 is equal to C2 is nothing but value for capacitor. What is the value for second capacitor? That is 1 farad. Second, and first capacitor it is 0.5 farad. So it will be, in this case, the second capacitor value is 1 farad and first capacitor value is 0. So your ratio will be V1 upon V2 is 0.5, 1 upon 0.5. What? So this is nothing but you will be getting 2. So I can write as V1 is equal to, you got twice of V2. That's the relation you got between V1 and V2. But I didn't want it a relation, but I wanted the value for voltage. When I say value for voltage, I wanted a value for V1 and V2. Now let's find how to get V1 and V2. Your V1 and V2 will depend on the circuit. If I say the circuit in previous case, if I see this circuit, if I find the total voltage across both the capacitors, that means this voltage will be equal to this voltage because we have a concept known as in parallel the voltage are same. So let's find the voltage across this term. So voltage across 4 ohms. If I get the voltage across 4 ohms, I'll get the total voltage across both the capacitors, right? So let's find the voltage across 4 ohms. So what is the voltage divisor formula? Voltage across 4 ohms is equal to total voltage, that is 6 volt, into we are applying voltage across 4 ohms upon addition of all the resistance. So addition of all the resistance means 4 ohms plus 2 ohms. So voltage across 4 ohm was total voltage into, we are finding voltage across 4 ohms, so total voltage into 4 ohms upon addition of both the resistance. So you got 4 plus 2. So voltage across 4 ohms is nothing but equal 4 volts. And you have seen your voltage across 4 ohms is equal to total capacitor voltage. And my dear friends, you have total 2 capacitors, so you can write VC1 plus VC2. So you will be writing voltage across 4 ohms is equal to VC1 plus VC2. And what is the voltage across 4 ohms? That is nothing but 4. So VC1 plus VC2 is equal to 4. And you have a relation between two voltage, V1 and V2, which you have already done it before, right, in previous case. So what you got? Your VC1 is equal to twice of VC2. So put this equation. So your VC1 plus VC2 is equal to 4. So put the value over here. So you will get 2 VC2 is equal to plus VC2 is equal to 4. So it will be 3 VC2 is equal to 4. So your VC2 voltage across second capacitor will be 4 by 3 volts. So when you got second, just put this value over here. You will get the voltage across first capacitor. So put this value. So you will get VC1 plus 4 by 3 equal to 4. Shift it that side. So VC1 is equal to 4 minus 4 by 3. This will be 4 3s are 12. 12 minus 4, 8. So VC1 will be, my dear friend, 8 by 3. So you got the voltages across both the capacitors. So you got how much your both the capacitors were charged. That was very important. Because when I start with t equal to 0 plus, it was said your capacitor was steady state. So I need to replace the capacitor by its voltages. Voltages mean how much your capacitor was charged. So let's draw t equal to 0 circuit. Now your t equal to 0 plus circuit, your circuit will be in this format, your switch will be closed, so you will be having a voltages that is nothing but 6 volt, you will be having a resistance that is nothing but 2 ohms, again you will be having a resistance that is nothing but your 4 ohms. For C1 you will be getting a voltage which is having 8 by 3 volts. For C2 you will be having a voltage that is nothing but 4 by 3 volt, and in this case you will be having switch will be closed. For inductor you will be having a current which is having a value of 1 ampere, and this will be your circuit at t equal to 0 plus. And it was said find the loop current. When it was said find the loop current, that means I had 3 loops in this circuit, so I need to get 3 values. So my first will be I1, second value will be I2, my third value will be I3. So let's find the value for I1, I2 and I3. Let's apply the equation. If you see, I can clearly apply my mesh equation in this because everything is a voltage. I hope you have seen the video for DC analysis. So a mesh concept will get clear over there much easier manner. So in this, I'll be applying mesh. So your mesh will be applying KVL, mesh 2, we get, so it will be 4 I2 plus, any other current flowing? Yes, minus 4 I1 equal to minus 8 by 3. That's equation number 1. So if I observe the other loops, I cannot apply my KVL over here because I have a current source. I cannot apply my KVL over here because I have a current source. So when you have 2 loops and you cannot apply a KVL because of a current source in between, so that property is known as a super mesh, which we have already studied in DC analysis, so we won't be going in that depth. So let's write the equation for super mesh condition, my dear friends. Applying KVL in super mesh. Let's apply the KVL across the super mesh. So in this case you get, so this is your resistance, there was a current source, this will be your super mesh condition. So you have only one resistance, my dear friends, so you will be getting 2 I1 0 plus equal to, there will be 3 voltage source, you have positive, negative, positive, negative, negative, positive. So over there you will be getting the value for I1 directly, which you can calculate in this form, bracket minus 8 into 3 inverse minus 4 into 3 inverse plus 6 bracket close divide by 2. So value which you got is 1 ampere. So after getting I1 value, put the I1 over here, so you can easily get the value for I2. So the value for I2 will be 4 I2 0 plus, it will be minus 8 by 3 plus 4 into 1. So simplify this value, put the value bracket minus 8 into 3 inverse plus 4 bracket close divide by 4. The value which you got I2 of 0 plus is nothing but equal to 0.33 amperes. Now when you say super mesh, the second equation which you obtain is from the current source. When you see the current source, the current is flowing in a downward direction and you have 2 adjacent current, I1 and I3. So just carefully observe which current source is observing that current source, and if you see it, your I1 is following that current source, so your value will be I1 minus I3 equal to 1 ampere, right? So you already got the value for I1. So value for I1 which you got in the above case was 1 ampere, right? So put the value for I1 over here. So cancel it, same sign, and the I3 value is nothing but equal to 0. So ultimately you got the value for I3 0 plus, which is nothing but equal to 0 amperes. So that was required to find in this sum. You had to find 3 values, I1 0 plus, I2 0 plus and I3 0 plus. Hope you understand this sum. Thank you so much. Take care. Thanks, signing off.